Hello, everybody. So, like William said, I will be talking to you about IoT today. Now, I know what some of you are thinking. Oh no, another buzzword talk. Just you wait, she's going to try to sell us some machine learning next. Maybe a blue one. But no, I'm not going to sell you a blue machine learning or a red IoT. I'm going to talk to you about code. There's going to be a lot of code. We're going to write a lot of code. We're going to talk a lot about code. We're going to talk about how to code for things. But first, let me introduce myself. So my name is Gergana, but I usually go by Jerry because that's a little bit easier to pronounce. And I work for a company called BBD. We make software, but I work on the R&D team. So for those of you who were at Mike's talk earlier, you've heard the spiel already. But we do things like consulting and training and research. But we also have a lot of fun. We do things like building meme generators and programming astromech droids. But more on that a little bit later. Now, two things I really love about my job is that I really get to do what I love. And one of those things is JavaScript, and the other one is IoT. And I know you're probably going to think I'm crazy when I tell you this part, but I love putting these two things together. Now, you're probably thinking I've taken the two most temperamental technologies and put them together. And yes, that's exactly what I'm doing. So a few years ago, I got a little BB-8 robot, and I wanted to program it because I got bored of the app quite quickly. So I did with JavaScript. And I've had a few talks on that, and some of you may have seen them. Then a few years later, I got a Parrot drone. Now, this is a really cool drone. It comes with this really fancy controller, and you can fly it really far away because the controller is really fancy. But I wanted to fly it with JavaScript. So I did, and this is how the first run went. It's a very simple lift off, hover for a few seconds, and then land. I was very impressed with this. I thought this was the most amazing thing. A little later that evening, my husband came home, and I was like, I need to show you what I've done with JavaScript. So grab the drone, grab the computer. By this stage, it was already dark, so I couldn't actually get the video of that. But this tweet came just afterwards. So the drone is okay, we fixed it. But all I'm saying is, just because you're going to crash a bunch of robots into walls with JavaScript, doesn't mean you shouldn't try. So, in preparation for this talk, I watched a lot of talks on IoT. I wanted to learn what other people are speaking about. And a lot of the talks talked more about the things, or building the things, or how the things work after you've uploaded your data somewhere. But one of the talks I really enjoyed, and there's a reference to it at the bottom here, which you probably can't see, but you'll be able to see in the video, split IoT into 4 separate parts. And I would like to talk about it in those 4 separate parts. Firstly, we get the hardware. Now, we're not going to talk a lot about the hardware that we're using because at the end of the day, we're software developers, so we don't do hardware very well. Then there's data. All of this hardware produces data. A lot of the talks, probably 2 out of every 3 talks, talked about the whole Gartner thing, about how many smart devices there's going to be and how many billions of petabytes of data there's going to be. To get that data, however, we need software. And that's where we come in. And lastly, and this is the part I believe is the Internet of Things. It's the connectivity. Because all of these devices, the light bulbs, the kettles, all of these things, they wouldn't actually be considered smart if they weren't connected. They either need to connect to each other or they need to connect to the internet in order to be smart devices. They need to produce something that's useful to us. So let's get to it. Firstly, the hardware. The hardware we're going to be using today is not very complex. So we're going to be using a Raspberry Pi. There's a number of different development boards you can use. I chose a Raspberry Pi because it's easier to program with JavaScript. Then we're going to be using a photocell resistor. Now, this is a variable resistor, and it measures the amount of light in a room. So I read a lot about this because I couldn't understand it, right? It's something about working on it with a Raspberry Pi. Raspberry Pi only has digital signals, so it's more complicated compared to an Arduino. And I was reading a lot about it, trying to understand how it actually works. And eventually I came across a developer's blog that said, well, if you really want to know how the hardware works, you should just Google it. So at this point in time, I thought, hey, my software is working. I'm just going to leave this alone. Then we're going to use something called a BME680. Now, this little chip measures temperature, humidity, pressure, and gas. And it's a complicated little chip. If you have a look at it, all of those gold strips that you see on the ends, all of those are pins that you need to somehow connect to your Raspberry Pi. And they go into different places in the Raspberry Pi. But instead of that, we're going to use this one. Now, this is a chip, exactly the same chip, but it's made by a company called X in a Box. This company builds Lego-like electronics. So these two little chips that you see there, they kind of clip together with a little clip and plug directly into one part of the Raspberry Pi. So you don't need to understand where exactly to connect it. You just plug it in. I have a little camera here, and I'm hoping this is going to work, to show you my setup. So you can see there is my photocell resistor. There's the Raspberry Pi over there, and that's that chip over there. I actually have two of them set up. One of them is my backup in case everything fails. So it's busy running in the background already, so I'll have something to show you if all else fails. Then we get to the data these things produce. So what are we going to measure? Well, we're firstly going to measure the amount of light from the photocell resistor. Then from the BME680, we're going to measure the temperature, pressure, humidity, and gas resistance. Now, why gas is measured in ohms? If someone knows, please come and explain it to me. Because I wasn't very good at chemistry in the first place, and there was this whole thing that I was reading about how it has to do with the periodic table of elements and the element numbers of oxygen and hydrogen and nitrogen. Yeah, I gave up. It's measured, but gas is measured in ohms. And using the humidity and gas resistance, we can calculate the air quality. Now, this is a calculation I found which is supposed to be standardized. It hasn't been yet, but it measures a percentage of the quality of air, where 100% is great air, and 0% is if you breathe this, you're going to die. So now, to get all of this data off of these devices, we need some software. And when you first start with IoT, the suggestions are C, C++, Python. This is because these devices have very small processors with very limited RAM. So you need some sort of low-level language to run in order to be able to get the data and run successfully. However, I was learning how to connect these things and how to make these devices. I didn't want to learn a new language as well. And I don't know C, C++, or Python. So I found the one solution which I usually go to when in doubt: JavaScript. So that brings me to my first demo, and we're going to write some JavaScript. Now, two people asked me while I was practicing this talk why I have my dogs on my demo slides. And that is because demos are stressful and my dogs calm me down. So let's get to it. So for our first demo, we're going to make 2 little JavaScript scripts that we're going to upload to the Raspberry Pi and run to see the photocell resistor working, as well as the BME 680 working. So let's start with the photocell. Firstly, we're going to import this library over here. This on-off library controls the GPIO pins on the Raspberry Pi. Then we're going to turn on GPIO pin number 5. Now, the reason we're just turning it on is because you can also plug this pin directly into the 3.3 volt pin on the Raspberry Pi, but I kind of ran out of pins because there's too many things plugged in, so I'm just turning one on. It does the exact same thing. Then we're going to create a function that will actually measure the amount of light. And what this is doing is it's measuring the amount of time the capacitor takes to fill up based on the resistance. So the darker it is, the more the resistor resists, therefore the capacitor takes longer to fill up. All right. Now we just need to call this. So if we manage to turn on the other pin successfully, we can call it. So every 1 second, we're going to call this and check how much light there is. Let's get this onto our Raspberry Pi. So first of all, we need to SSH onto our Raspberry Pi. And you may notice, as I'm typing this, that all of my Raspberry Pis are named after astromech droids. Why? Why not? Okay, and I've set up all of the directories already because I don't want to waste your time by running npm install in every single directory, because that might take a while, especially on this conference Wi-Fi. So you can see that we've only got node modules and package.json in here. So we need to SCP that JavaScript file we just created into the correct directory, which is that light sensor directory. That gets copied across. So now if we OS, it's there. So we can run it using node. We can just go sudo node. And it starts running. Cool. So you can see there's just a reading being printed there. And if I cover up the resistor, the reading goes up. And goes back down. Next, the temperature. Well, it actually senses a whole bunch of stuff, right? Temperature, humidity, pressure. So I just called it weather. I don't know. I'm bad at naming things. So firstly, we're going to import a library. Again, we're using another library to help us with the complex parts of connecting to the things, because we just want to write the code, right? We don't want to care that much about how those things work. Then we're going to just call read. And that reads out those 4 values. For now, we're just going to log them. But in order to calculate that air quality value, we need to actually get a gas reference. So the gas reference is pretty much just getting the gas 10 times and averaging it, because it's not a very accurate measurement every time. And once we have the gas reference, we can, is it 4? Yes. Calculate the air quality. So the way this calculation works is it pretty much takes 25% from the humidity and 75% from the gas, and put some sort of limits on it. So you can see that the bad air quality limit is 5,000, and the good air quality limit is 50,000, and works out the air quality based on that. So the lowest I managed to get the air quality was to 81%, and that was by someone actually blowing smoke on it. So I think it has to be really, really bad in order for it to get that low. Like it has to be poisonous air in order for it to be that low. And then in here, we're going to call the calculate air quality and also just log it to the console for now. and then call the guest reference again. And at the bottom, I'm just going to add another set interval so it calls every 5 seconds so we can see it repeatedly. All right. Now we need to get this across to the Raspberry Pi as well. So let's SCP to the weather folder and get to the correct directory on here. And we can, again, I've installed my modules beforehand, sudo node weather. All right, and if nothing fails, we have temperatures, pressure, and the air quality in here is 98.69%. Pretty good. All right, so this is all great, right? And we have all of this data that we're getting now. But what do we do with this data? I mean, you can't just be SSH'd into a Raspberry Pi and watch it on the console logging. And that's where our connectivity comes in. Now, when I first started this talk, I was doing research in another cloud provider. But there's so many options out there, right? So we have Microsoft, Amazon, Google, IBM. All of these options are all viable options, and they all provide us with good ways of doing things. But I thought, since this was for DevFest, that I should make my talk more googly. This was my first option. I thought that the GDG organizers wouldn't be too impressed with my interpretation of googly. Then I also wore my Chrome socks. But I didn't think that would be enough. So I didn't think that would be enough. So I decided to go for Google Cloud IoT Core. So Google Cloud IoT Core is actually pretty cool. There's two ways to set everything up for your devices. There's, by installing the SDK, you can run everything in your command line, or you can use the browser clicky way to do everything. And since I prefer clicky ways of doing things, I went for the browser. So what you do is you first create a project. Then, when you click on IoT Core in the side menu, it prompts you, do you want to enable the API? So you enable the API. And then it prompts you, would you like to create a device registry? Your device registry is where all your devices get put in your IoT Core, almost like a little hub for everything to be put together. When you create your device registry, you also need to create 2 pub subtopics. Those topics are for telemetry and state data. You can create it as the same one, but it's good to keep them separate so you can keep the different data separate. Once you've created your device registry, you can start creating your devices. However, in order to make sure your devices are secure, the way IoT Core works is your device always creates a JSON Web Token, which it encrypts and signs and sends it to IoT Core, and IoT Core has the public key in order to decrypt it and make sure that the device sending the data is actually the correct device. So you have to create a public and private key pair. You have a few options on the algorithms that you can use here. I chose to use the RS-256 algorithm, and that's the commands you use for creating your public and private key pair. Once you're done there, you can just create your device. Now, it's important when you're creating your device to name it something that you will remember and make sense to the project you'll be using it for, because you can't change the name afterwards. So that's an important thing to remember. So let's get to our next demo. First thing we're going to do is make some changes to our code that we have over here. So we're going to firstly get rid of this else, because we still need to turn on this pin, but we're not going to call the thing every 1 second. And I'm just going to put this inside a function. A function called init power, which we're going to call from our main script. All right. And then at the bottom here, we're just using module exports, going to export our 2 functions so we can import them into the other file. That one's done. Now in this one, we need to make a few changes. So we can get rid of the set interval call at the bottom. We can also get rid of the console logs. And instead, in here, we're going to create a new object which will read all of the data from the sensor and also calculate the air quality. And we're also going to add a current time. So the reason for the current time is so that we can see later on when we're getting this data, when this data was sent through. And don't forget to export. Then this file over here is just a helper file that I created with all of the variables for connecting to Google Cloud IoT Core. So my project ID is IoT Cloud Stuff. The region we're using, Western Europe. Registry is IoT Registry. My device's name is BB8Pi. And then this is the private key file, which is stored on the Raspberry Pi already. So it's just going to read it from there in order to create the JSON Web Token. All right. Now we're going to first import a few libraries. The libraries we're going to be using is firstly the file system library, so that we can read that private key file. The JSON Web Tokens library, so we can create a JSON Web Token to send to IoT Core. The MQTT library, because that's how we're going to send data to IoT Core. And then our 3 files that we already spoken about. Then a few other constants we need. The MQTT bridge on Google Cloud and the port number, as well as the algorithm we use to sign our JWT. Then we have a function for creating our JWT. This just uses that JSON Web Token library and reads in the private key file and signs the token so that it can be validated on the other end. Then we need a few other plumbing things. So we need the MQTT client ID. So this is like a fully qualified URL of exactly where this device lives on IoT Core. So you can see there it's in this project ID, in this location, in this registry, and that's the device we're talking about. All right, and it's getting all of that from that args file that we spoke about earlier. And now, having all of these things, we can create our connection arguments. So we pass in all of these things. One of the interesting ones here is the username. So because it uses a JSON Web Token, Google Cloud doesn't need a username. But it doesn't mean you can leave it out of the connection arguments, so you still have to put something there. So you can put like not applicable or unused. Okay, and with our connection arguments, we can now connect. Connect. In order to connect, we just call mqtt.connect and pass in our arguments. And then we subscribe to our device. Now we need to wait and listen for IoT Core to tell us that it's connected, that our device is connected to it. In order to do that, we just listen to the connect event. And if it successfully connects, we can now do things. what are we going to do? Well, we're going to take all of our data that we're creating and push it to the cloud. So over here, we're going to create another function. That one. Lost count. So the function will have a MQTT topic, which is publishing to the device ID's events. Events is where the telemetry data goes. So we're sending telemetry data. If it was state, then this URL here would be state. And then we call all of our functions that we created, the measure all, the get light reading. And we also set the device ID so that when we get it on the other end, we know which device it was that was sending the data. We stringify our data, and we publish it to the client. And then I've added a few console logs here for debugging purposes, just to make sure everything was working. And in here, we now just need to call our method. So we'll first initialize power to the photocell resistor, and then every 5 seconds, we're going to publish our data to the cloud. Now, you would think that this is enough, right? Because it is technically enough. However, if your connection dies, or if you kill this script, then your bridge to IoT core is still open. So all we need to do is clean up after ourselves. And to do that, we just call client.end and a little message that says goodbye. So we listen for the close event and close that. So if we've done everything correctly and we get it across to our Raspberry Pi, we should see it working. So in here, you can see that I currently just have my node modules. So we're going to SCP the args. From the photocell to combined directory. To the combined directory, and then lastly the index. And let's just make sure we copied it to the right place. Looks like it's all there. And if nothing has failed, we're going to see connect. And any minute now, it should publish a message. There we go. Started publishing messages. So now that we're publishing our data to the cloud, what do we do? Well, here you have a few options. We have our data in a pub subtopic on Google Cloud. So using the pub subtopic, we can push the data to Cloud Functions. In Cloud Functions, do something with that data and push it back to the device so that it knows what's happening with its data. We can also put it into Dataflow. Using that, push it into Bigtable and store the data for later use for some reason. Or you can push it into BigQuery. Now, from BigQuery, you can make changes to the data and then put it into machine learning. Now, from machine learning, you can learn from the data and feed back to the device so that it changes the way it does things, if that's what you wanted to do. There was actually a really cool example of one of the talks I watched, where they had taken sensors very similar to these ones that were measuring the air quality in an office building and sounding alarms when something had gone wrong. So if the air quality reduces below a certain amount, sound the alarm to make people leave the building. So it's kind of like a smoke detector, but way cooler because it's connected to the internet. Now, these are all great options. However, I promised you code. So, what are we going to do? We're going to use JavaScript to get our data off the cloud. Now, this demo is a little bit different because it's already running, and I'm not going to live code it. So I'm just going to explain to you what it's doing, and then I'm going to show you it. So, first of all, we need a library from Google Cloud called PubSub. Using this library, we can create a new subscription. Now, to connect to PubSub, we initialize it by giving it a project ID, which is my IoT Cloud Stuff project ID, and then a key file name. So this key file name is a file with a service account which you've created on IoT Core, which has access to that data. This was something I learned about IoT Core, which is actually really cool. So at first, I was just hacking away trying to get the data off this PubSub topic, and I kept getting an unauthorized error. But then I actually read the error properly, and just underneath, don't laugh at me, just underneath where all of the stack trace of the error is, it says, go to this link for help. And you click on the link, and it tells you exactly how to fix your problem. It's actually really cool. So it told me how to create my service account and how to put it into my code. And then we need a subscription, the actual subscription. Mine is called IoT subscription. And then you just call pubsub.subscription and give it the name. Once you have your subscription, you can listen for messages and create some sort of handler to handle your messages. Now, the message that comes back has data on it. So the data is the data you're sending to the cloud. And then it also has a bunch of attributes. The attributes are really cool because they have things like what device it was, what state the device was in at the time. And you can use those attributes to validate that you're getting the data from the correct place. And at the bottom, you can see that we acknowledge the message. This is also another nice setting that they have on subscriptions, where you can say, after I've acknowledged the message, delete it permanently. Otherwise, if you don't check that checkbox, it will keep the messages in the PubSub topic for 7 days. I think it was 7 days. Yes. And then, of course, you have to clean up at the end. So if the script gets killed, we remove the message handler. So, on to the demo. Wait, this one's just here. So if nothing has gone wrong, these things have actually been updating all along. I hope. Yes, you can see that one's time updating. Is the other one updating? No, the other one's dead. My backup Pi died. The one we programmed is still going. But you can see every 5 seconds on this one here, it's updating, and the values are changing. Okay. So this is all fun, and playing with this stuff is quite a lot of fun. I've had a lot of fun setting all of this up. But let's talk about the real world, right? Some real world examples I've come across is, this first one is more for people living in America. It doesn't really apply to us, but it's called the Amazon Dash button. So if you have an Amazon Prime account in America, you can get these buttons, and this is a washing powder one, but you can get for a whole range of products. And you push this button, and your Amazon Prime account has all your banking details and everything, and it takes the money directly off your account, and the next day you get your washing powder delivered. it's pretty cool. But more on a local context. Now, a lot of our supermarkets have this problem where they lose their trolleys. And apparently they spend millions of rands every year getting more trolleys. So this is something that a company here came up with, where they put little beacons on the trolleys, and then they put antennas around the supermarket. So when a trolley goes out of range of those antennas, the supermarket gets notified and someone can go and fetch the trolley, which is pretty cool. And then the last one is a beer keg tracking system. Now, this system is pretty cool for the people who make the beer, because they put these devices on their actual kegs, and they can find their kegs. They know where their kegs are. But the other thing that's cool about it is there's also a consumer app for it. So you can install this app on your phone and see where the beer that you like the most is, and see how fresh it is, see when it arrived there, see what temperature it's at, before you go to that pub, so you know. Now, I know you're all probably feeling like this right now, but I do have one more thing to show you. My big red button. Now, beer is okay, I'm okay with beer, but I really, really like wine. So this button lives underneath a wine rack at home. And whenever the wine rack gets low, I can push my wine button. And it goes to my favorite wine farm's website and adds a bottle of wine to my cart. Every time I push the button, it adds a bottle of wine to my cart. Now, I was really disappointed to find that my favorite wine farm's website is so terrible. So I apologize for that. But that is my favorite wine, so. And on that note, thank you very much. Let's go drink some wine. I mean, are there any questions?
Can I have the button?
I will build you one.
Hi, Gergana. I just wanted to ask, when you buy devices, like you mentioned the drone that you wanted to program, was it a specific, did you buy that specific drone to program it, or can you just like choose anything to program?
So the drone and the robot were both presents. So I didn't necessarily mean to program those things. Those are the things I had. Pretty much anything you come across. If it has an app, you can probably program it. I don't ever settle for apps that other people build.
Okay, so the Raspberry Pi, see, I'm here.
Oh, sorry, yes. I couldn't see who was talking.
So the Raspberry Pi is, can I see, is it small? Is it something that you can embed? I'm thinking of packaging, okay? So just like you have the red wine button, is that what you have in there? Or is it just for simulations, and then later you get like a different chips for you to like do the real thing on?
Yeah, so I would say the development boards like the Raspberry Pis are more for when you're prototyping, and then when you get to building the actual thing, you would probably design the board and get someone to make you the actual board.
Okay.
Yeah.
So how did you get the dogs to always be like camera ready?
This is 5 years worth of photos of dogs that I had to troll through to find those three, okay? Anyone else?
So I think you kind of talked about this, but why must you insist on JavaScript?
I think Mike should take this question. No, I just, so the reason in this case that I wanted to do JavaScript was because I was learning new things, and I wanted at least some part of something I feel comfortable in, and which is JavaScript. So that's pretty much why I chose JavaScript. And also because people hate on JavaScript so much, right? But I wanted to prove that you can do anything with it.
Yeah, quick question. Very cool demo, thank you. I just wanted to ask, how long did it take you to come up with this? And were you learning from scratch or you had prior experience?
Sure. So this whole setup, I've been planning for about 2 months, maybe. Yeah.
Hey, Gary.
Hey.
Yeah, so just to follow up with what she was asking about JavaScript. Yeah, so on a scale of like 1 to 10, how would you say the availability of libraries, JavaScript libraries for doing stuff like this in IoT? Like, would you recommend using it? Would you recommend going with more low level?
That's actually that's a good question. With most of the libraries, I found it by the second time I Googled. There's a lot of libraries out there, and especially so for the Raspberry Pis, that's also the reason why I went for a Raspberry Pi. With Raspberry Pi and Arduino, there's a lot of JavaScript libraries out there, whereas with the other more complex and smaller microcontrollers, there aren't as many. So that's why I went with a Raspberry Pi actually as well. Cool. Thumbs up. Oh, I do have to ask a question. Sorry, I have to ask you a question because I have a thing to give away. Cool. So we're going to try to do the first hand up thing. William is going to help me figure out who put their hand up first. No, wait, put your hands down. Okay, so why did I need a capacitor? I think that hand up was first.
You need a capacitor to slow down the responses, otherwise you'll just overload. So you need a resistor and the capacitor charges, otherwise it's just always just a signal.
Yes. Cool. Thank you, everybody.